Artificial intelligence. The term may sound like something straight out of a science fiction movie. But what if I told you it's not just the future? It's already here. From simple machines to systems that can beat world champions in chess, artificial intelligence has come a long way. Today, we're diving into the evolution of artificial intelligence, from its humble beginnings to shaping the world of tomorrow. To understand the evolution of artificial intelligence, we must begin at the very start, the birth of an idea that would one day transform the world. The year is 1950. In post-war Britain, a brilliant mathematician named Alan Turing poses a groundbreaking question. Can machines think? This wasn't just theoretical, it was revolutionary. Turing, often called the father of modern computing, had already played a crucial role in World War II, breaking the German Enigma code, but his imagination extended far beyond wartime cryptography. In his seminal paper titled, Computing Machinery and Intelligence, Turing introduced what we now know as the Turing test, a method to determine whether a machine could exhibit human-like intelligence. The test was simple in theory. If a human could converse with a machine, and not distinguish it from another human, the machine could be considered intelligent. It was the earliest formal attempt to define what machine intelligence could mean, but it wasn't until 1956 that the term, artificial intelligence, was officially born. A group of scientists gathered at Dartmouth College in the United States. Among them were John McCarthy, Marvin Minsky, Alan Newell, and Herbert Simon, names that would go down in AI history. They believed that machines could be made to learn, reason, and even improve themselves. Their proposal was bold. They stated that every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. From this conference came early programs like Logic Theorist, created by Newell and Simon. This program could prove mathematical theorems, something that shocked many in the academic world. Artificial intelligence was no longer just science fiction, it was becoming a science fact. The excitement was contagious. Researchers believed that within a few decades, machines would rival human intelligence. Funding poured in, experiments began, but the journey was just beginning, and the path ahead would be anything but easy. The birth of artificial intelligence was marked by incredible optimism, bold imagination, and groundbreaking ideas. But soon, reality would check in, and progress would hit its first wall. Every great story has a setback. And for artificial intelligence, that setback came in the form of not one but two long, cold periods of silence, known today as the artificial intelligence winters. The first artificial intelligence winter began in the mid-1970s. At the time, the buzz around intelligent machines had reached a fever pitch. People were convinced that artificial intelligence would soon rival the human mind. Governments, especially in the US and UK, began pouring money into artificial intelligence research. But there was one problem: artificial intelligence couldn't deliver on its promises. The machines could play chess and solve equations, yes, but they couldn't understand basic language. They couldn't see the world. And worst of all, they couldn't learn without being told exactly how. In other words, they were brittle, limited, and expensive. Artificial intelligence had hit a wall. Disappointed by the lack of progress, funding agencies began pulling out. Projects were canceled. Universities shut down their artificial intelligence labs. Researchers abandoned the field. The hype turned into doubt, and the once burning dream of intelligent machines froze over. This period became known as the first artificial intelligence winter, and it lasted nearly a decade. But just as the field started to recover in the 1980s, a second winter crept in. By the late 1980s, the world became obsessed with a new artificial intelligence trend: expert systems. These were programs designed to replicate the decisions of human experts, doctors, engineers, financial analysts. They worked well at first, but they came with a fatal flaw: they couldn't adapt. Every rule had to be programmed manually. Every exception had to be handled separately. And if new information came in, the system broke. So once again, funding slowed, interest declined, artificial intelligence slipped back into obscurity. These winters weren't just about lack of money, they were about broken expectations. They reminded us that intelligence, true intelligence, is more than just logic. It requires learning, flexibility, context. The artificial intelligence community went quiet but not dead, because deep beneath the surface, a new revolution was brewing. A revolution powered not by rules but by data. After 2 brutal winters, the dream of general artificial intelligence, machines that could think like humans, was nearly frozen. But artificial intelligence wasn't dead. Far from it. It was simply changing form. Enter the 1980s, a new chapter in the story of artificial intelligence. Instead of chasing human-like intelligence, researchers turned their attention to something more practical: expert systems. Rather than trying to mimic the entire human brain, these programs aim to replicate the decision-making of domain-specific experts, like doctors, engineers, or lawyers. Imagine you're a doctor diagnosing a disease. You follow a series of questions and symptoms, eliminating possibilities until you reach a conclusion. An expert system could do the same, but faster, with a vast memory and no coffee breaks. The most famous example, a system called Makin, developed in the early 1970s, but refined in the 1980s. It could diagnose bacterial infections in blood and recommend treatments, sometimes even better than a junior doctor. At their core, expert systems work by using if-then rules. If symptom A and symptom B are present, then suggest diagnosis X. These systems could contain thousands of such rules, a digital reflection of human expertise. This was narrow intelligence, not general intelligence. But it was useful. Banks used expert systems for loan approvals. Airlines used them for scheduling. Factories used them for monitoring equipment. It felt like artificial intelligence was finally fulfilling its promise, not by thinking like us, but by working with us. Funding returned. Optimism grew. But there was a catch. Expert systems were brittle. Every rule had to be hand-coded by humans. If the world changed, if new symptoms emerged, or exceptions occurred, the system couldn't adapt. It had no common sense, no ability to learn. Over time, maintaining these systems became a nightmare. The same lack of flexibility that doomed early artificial intelligence reappeared. And by the early 1990s, expert systems, once seen as the future, were fading fast. Still, they had served a crucial purpose. They kept the field of artificial intelligence alive. They proved that machines could be useful, even if not truly intelligent. And most importantly, they taught researchers a powerful lesson: to build machines that truly think, you don't need more rules. You need learning. And with that realization, the next evolution of artificial intelligence was born, one that would change everything. By the early 2000s, expert systems had faded. Rules were no longer enough. The world was changing too fast, and the problems were too complex to be solved by hand-coded logic alone. Then something incredible happened. Instead of telling machines exactly what to do, researchers tried something bold. What if we let the machine figure it out on its own? This marked the birth of machine learning, a breakthrough that didn't just change artificial intelligence, it transformed the way computers interact with the world. So what is it? At its core, machine learning is the idea that machines can learn from data. Instead of writing rules, we give the machine examples, patterns, outcomes, and over time, it learns to make decisions on its own. Let's say you want an artificial intelligence to recognize a cat. In the old days, you'd have to define rules: 2 ears, 4 legs, whiskers. But with machine learning, you don't give it rules, you give it thousands of cat photos. The artificial intelligence finds the patterns. It learns what makes a cat a cat. This shift was revolutionary. Suddenly, machines were not just reacting, they were adapting, learning, improving. This is what powers spam filters that learn from what you delete, language translators that get better the more you use them, and recommendation engines that know exactly what video you'll click next. It's how Facebook tags your friends, Google finishes your sentences, and Netflix predicts your next binge. But the true superpower behind machine learning lies in its most advanced form: deep learning. Inspired by the human brain, deep learning uses something called artificial neural networks, layers upon layers of digital neurons, that simulate how we think, see, and even feel. Deep learning is what gave us voice assistants that understand us, image recognition that detects tumors, self-driving cars that can see the road and make decisions in real time. It brought artificial intelligence into our daily lives, not just in labs, but in our phones, homes, hospitals, and cars. And the more data we create, from our searches, our photos, our movements, the more these systems learn. We are teaching the machines, even when we don't realize it. Machine learning didn't just change artificial intelligence, it rebooted it. It gave artificial intelligence a second life, not as a dream, but as a reality. And with it, the race toward a truly intelligent future had officially begun. If machine learning was the spark that reignited artificial intelligence, then deep learning was the fire that turned it into a global revolution. Deep learning is a form of machine learning, but on another level. It mimics how the human brain works by using artificial neural networks, layers of interconnected nodes, or neurons, that process information step by step. Here's how it works. Imagine you want an artificial intelligence to recognize a face. The first layer might detect edges and lines. The second layer picks out shapes, like eyes or a mouth. The next layers combine those parts into a full face. And finally, the last layer says, "That's Sarah." This step-by-step transformation, from raw pixels to full understanding, is the magic of deep learning. Deep learning gave artificial intelligence something it never had before: intuition. The ability to figure things out without being explicitly told how. That's how Google Translate became fluent in over 100 languages. How Tesla's self-driving cars learn to make decisions on the road. How chatbots and voice assistants can hold conversations that feel, well, human. And it's not just language and vision. Deep learning is revolutionizing healthcare, finance, entertainment, and even science itself. It's helping radiologists detect cancer earlier than ever before. It's identifying fraudulent transactions in milliseconds. It's composing music, painting portraits, writing books, blurring the line between creation and imitation. But here's what makes deep learning truly astonishing: it gets better with more data and time. Every search you make, every photo you tag, every voice command you speak, the system learns from it. Each interaction strengthens the neural network. It's like giving artificial intelligence more experience and more life. Today's deep learning models can write poetry, compose symphonies, design buildings, and even debate complex topics. Some can generate realistic human faces, people who don't actually exist. Others can simulate voices that sound indistinguishably human. We've crossed into a new era, where machines no longer just compute, they create, adapt, and evolve. Deep learning has taken us from programs that follow rules to systems that understand patterns to models that can now dream up solutions we never imagined. But as the line between human and machine blurs, one question grows louder: how far will this go? For decades, artificial intelligence was a dream. Then it became a tool. Now it's everywhere. We're living in the age of artificial intelligence, and most people don't even realize it. Every time you unlock your phone with your face, artificial intelligence. Every time your email filters out spam, artificial intelligence. When Netflix suggests your next favorite show, artificial intelligence. But behind the scenes, artificial intelligence is powering something even bigger. It's optimizing traffic in smart cities, analyzing medical scans faster than human doctors, managing entire supply chains for global businesses. In agriculture, artificial intelligence is helping farmers detect plant diseases before they spread. In energy, it's forecasting power usage with near-perfect accuracy. And in finance, it's executing billions of dollars in trades in milliseconds. This isn't science fiction. This is today. Even in our homes, artificial intelligence is quietly reshaping how we live. Smart assistants like Alexa and Siri respond to our voices. Smart fridges monitor what we eat. Smart thermostats learn our preferences and save energy. The more we interact with technology, the more it learns, and the more it becomes woven into the fabric of daily life. In schools, artificial intelligence tutors are adapting lessons to individual students. In courtrooms, algorithms are helping determine bail and sentencing, a fact that raises serious questions. Because while artificial intelligence can solve, it can also amplify bias, injustice, inequality. And in the military, artificial intelligence is being developed to power autonomous weapons, machines that can identify and eliminate targets without human input. The implications are staggering. So yes, artificial intelligence is helping us live longer, learn faster, and work smarter. But it's also forcing us to confront new ethical dilemmas. Who is responsible when an artificial intelligence makes a bad decision? How do we ensure artificial intelligence is fair, transparent, and accountable? And perhaps most important, how do we stay in control of the machines we've created? The age of artificial intelligence has arrived, and what happens next is up to us. Just when we thought we understood artificial intelligence, it evolved again. In recent years, a new wave of technology has emerged, one that doesn't just analyze the world, but can actually create it. This is the age of generative artificial intelligence, a branch of artificial intelligence that can generate text, images, music, code, even entire worlds. Give it a few words and it writes an entire story. Feed it a melody and it composes a symphony. Type a sentence and it paints a picture. You've probably already met generative artificial intelligence, maybe without even knowing it. Tools like ChatGPT can hold fluent conversations, write essays, debug code, and craft poetry. DALL-E and Midjourney turn words into stunning art in seconds. Runway and Sora can generate videos that feel eerily real. It doesn't stop there. Generative artificial intelligence can mimic your voice, or recreate one that never existed. Can generate deepfake videos so convincing, they blur the line between truth and illusion. In Hollywood, artificial intelligence is now editing trailers, de-aging actors, and even writing scripts. In medicine, it's designing molecules for future drugs. In architecture, it's sketching entire cityscapes from a single command. We've entered a time when machines can imagine, not just calculate, but create, not just respond, but inspire. It's thrilling, it's powerful, and it raises a big question. What is creativity, really? Some say generative artificial intelligence is the greatest creative tool in human history. Others worry it could replace artists, authors, musicians, and even erase trust in what's real. One thing is clear: generative artificial intelligence is not the future, it is now. And it's redefining what it means to be human in a world where machines can imagine. In this new era, the question is no longer just, what can artificial intelligence do? But rather, what will we let it become? So here we are, standing at the edge of something extraordinary. In less than a century, we've gone from punch cards to neural networks, from solving equations to machines writing poetry, from dreaming of artificial intelligence to artificial intelligence dreaming with us. But the question is no longer can we build intelligent machines. It's, what kind of intelligence are we creating? And what kind of world will we build with it? In the next decade, artificial intelligence will touch every part of life. Doctors may rely on it to diagnose disease. Teachers will use it to personalize learning. Governments will use it to predict crime, manage cities, and shape policy. And perhaps, artificial intelligence may even help us discover life beyond Earth. But with great power comes a deeper responsibility. How do we control systems that can evolve faster than we can understand them? Who decides what's ethical when the machine has no soul? Can we trust artificial intelligence to be unbiased if it learns from a biased world? What happens when an artificial intelligence writes laws or wages war? When it creates art that moves us more than human hands ever did? These questions don't have easy answers. But one thing is certain: the future of artificial intelligence is not just about algorithms. It's about us. Our values, our choices, our humanity. The next era of artificial intelligence won't just be about what machines can do. It will be about what we allow them to become, and what kind of future we choose to shape together. This is not the end of the artificial intelligence story. This is just the beginning.